All right, so we're gonna do eye clicker questions, so make sure you have your eye clicker ready. Wait. Ask me again? Yes, yes. So the thing with the book bundle was if you, regardless of whether you did the book bundle or not, if you got the handheld eye clicker from the bookstore, it should have come with a 5-year subscription to the app on your phone. That should get you through every class for all of college with the purchase of one handheld eye clicker, right? So if you were using the handheld eye clicker and then you hit that paywall after the 14 days, what you have to do is you have to go in and make an account and link your handheld eye clicker so they know you bought a handheld eye clicker and therefore get the subscription. So that's what the instructions that I sent y'all were. Does that make sense? Okay. And then everybody's okay accessing the book and accessing the homework. That was a mess this weekend. Holy moly. But I think we're all figured out. If you, did anybody, I do want to ask this, did anybody who opted out, paid for the subscription themselves, you go to course materials, and the only option you have is no longer the ebook or the My Lab and Mastering, right? There's only one thing and it says buy now. Okay, if you click buy now, it takes you to the bookstore's website. Is there a button on the bookstore's website that says I purchased my subscription?
Mine takes me straight to Pearson after. Like we have to click buy now, it takes me straight to the website.
See, like it's not like it's not figured out. Now that's why I have more than one solution. So some people can do that, and that's great. Some people can't, and if you can't, like when you click buy now, if it doesn't take you to Pearson, then if you bookmark Pearson, you can go straight to the Pearson site and do your homework that way. Now, last semester, y'all couldn't do that. It was a huge no-no and it messed with the system. You had to go through Moodle, which is why I said, don't do that. But they changed the rules with the book bundle and how everything works. So now you can.
So now we can go straight from Pearson.
As yes.
Okay.
Yes. There's no button. See, that's what I thought too, but I argued with the bookstore, but
You know, it was like the entire time, it's like going straight to like through Pearson. And I was like,
well, so now it's supposed to work. It's supposed to be fine. So I'm going to try and import grades and all that this week. Yes, sir. Is that what Pearson said? That's what Pearson said. See, and we get in different information, whether it's the bookstore, whether it's Pearson, like everybody's coming with different information because it's the book bundle, y'all.
When the bookstore
that's where it's all getting messed up. Yeah. Uh-huh. Well, they weren't ready for this. Nobody was ready for this. No one. We weren't. Pearson wasn't. It's not Pearson's fault. It's not. Don't let me go down the road on whose fault it is. I'm not going there. I'm not going there. Okay. What do you call a cow that just had a baby? Decaffeinated. Decaffeinated. That's cute. All right, make sure those masks are over noses and mouths, please. Y'all ready for your eye clicker? Get them out. And if you're using the handheld, it does say ready, correct? Okay, good. Okay, so here we go. Eye clicker question number 1. Select the inorganic compound. Select the inorganic compound. Better if I scroll up a little bit. Sorry. Always tell me. You know what organic is? Should know what organic is. Inorganic is the opposite of organic. Define, don't talk right now, don't talk right now. Define organic, and which one of these does not fit the definition? Okay, oh, I was supposed to say 10 seconds. So 10 seconds. Supposed to be 1 minute, it's 10 seconds. So 1:10, I'm gonna close it. Make sure you don't leave it blank. Okay, so now turn to the people around you and discuss. Which one is the inorganic compound? 30 seconds. Noses, cover those noses. All right, you should have clicked in again. Make sure you click in again. I see some people have not. Please click in again. I'm closing it at 45. Closing it at 45. Click in again. Okay, so what did we say? All right, so let me ask you this. So we're divided. We're a pretty divided class here between B and E, right? Okay, what are organic compounds? Means we have carbon and hydrogen, carbon and hydrogen. Okay, do y'all remember the classes of molecules, the biomolecules that we said were all organic? Do you remember this from last time? Proteins, carbs, lipids, and what else? And what? Nucleic acids. What are nucleic acids? DNA, y'all. DNA, RNA. Okay, so proteins, what do we think? Yes or no? This must be what? Organic. B, Na2CO3. Does it fit the definition of organic? Do you see a hydrogen? Because I don't see a hydrogen. Here's my answer. C6H12O6. Do I see carbons and hydrogens? Check. What is that? Anybody know? Sugar. It's a sugar. DNA. Organic? Absolutely. Gasoline. Gasoline is a hydrocarbon. Do y'all remember we were talking about putting dinosaurs in our gas tank earlier in the semester? Do y'all remember that? Right? Okay, between me and a dinosaur, do both of us have proteins? Yes. Do we both have carbs? Yes. Do we both have lipids? Yes. Do we both have nucleic acids? Yes. Are we both organic organisms? Yes. So when I degrade and break down, I will not turn into gasoline because, that'll be a really long time. It's probably not going to happen. But that's where we get fossil fuels, from organisms that have broken down and degraded inside of the earth and have turned into sludge. And then we process it and we turn it into gasoline. So gasoline is hydrocarbons, carbon and hydrogen, right? Okay. Sometimes the simplest answer is right. Okay. So B, how many did we say before? Oh, well, it looks like those people who stuck with it. So that's good. All right. Oh, we did that. Okay. How many carbon-hydrogen bonds are present at the indicated carbon? So look at the indicated carbon, which is this one right here. How many carbon-hydrogen bonds are present? 1 minute. Okay, 10 seconds. Make sure you've rung something in. All right, now turn to your partners, turn to your friends, turn to your neighbors, talk. Do not lower your mask though while you talk. Still here talking, so I'll give y'all till 1 minute. I'll give y'all till 1 minute. Make sure you check in again. Okay, 5 seconds. Make sure you check in again. Please put another response in. We had about 42. So we still need a few. Come on. All right, so what did we say? Oh, we're still divided. Oh, we're still divided. All right. How do you know? Translate this to a Lewis structure. So how many carbons do I have? 2, 3, 4, 5. And then I have 1, 2 carbons coming off of that third carbon, right? So I'm going to go 1, 2, 3, 4, 5. And coming off of that third carbon, I'm going to go 1, 2, right? Now, I have to draw in my carbon bonds first. Do I have any double bonds? No. So all you do is draw a line to connect all your carbons. Then you give the carbons enough hydrogens to complete their octets. So carbon 1 gets how many hydrogens? Carbon 2 gets how many hydrogens? Carbon 3, this is the indicated carbon. This is the indicated carbon, gets how many hydrogens? 1. So it should have been D. Should have been D. Okay, carbon 4, how many? 2. Carbon 5, how many? Okay, this carbon coming off of carbon 3. 2. This carbon. 3. Scroll down, yes. Do you understand? I was not asking how many carbon-carbon bonds. If I asked how many carbon-carbon bonds are on this carbon, how many would you say? 3. But if I ask how many hydrogens, then you have to go in and fill in the gap. Okay? Yeah? All right, I think one more. I think I have one more I want to do. Yeah, okay, this is the last one. Last one. I want to make sure it's all the way on the screen. All right, so identify the correct skeletal line structure for this compound. So you're going to take this compound and you're going to turn it into the skeletal diagram. I'll probably give you 1.5 minutes on this one because you're counting carbons and all that. What? The network, try again. Okay, there it goes. Remember, I'll give you all a minute and a half. Okay, 10 seconds. Okay. Turn and talk to your partners, talk to you people, come up with another answer. Mask, please, everybody. Noses and mouths, thank you. Are we done discussing? All right, make sure you put in your answer. Give y'all 10 seconds, put in your answer. Okay, so what do we say? Oh wait, this is the wrong question. I already graded that one. Okay, so now we have, good. So we went up, we went from 83% to 93, good, it is A. So when you do this, do you notice that it's not in the same conformation? You see that it's kind of rotated, it's kind of moved around. What did you do to make sure that you knew it was A? Did you count your carbons? Yes, you counted your carbons, all right. So you look for your longest chain of carbons. So my longest chain of carbons is not straight across, right? If I went straight across, that'd be 1, 2, 3, 4. That's not my longest chain of carbons. What's my longest chain of carbons? 5. 1, 2, 3, 4, 5. Then I have a CH3 group and a CH3 group coming off of 2 and 3, right? So do I have something like that? Sure, I'm going to go 1, no, I'm going to go this way, 1, 2, 3, 4, 5. So I have a methyl group or a CH3 group. That's what these are called, methyls. METH, methyls. So I have one coming off of 2 and I have one coming off of 3. Right? Good. Awesome, y'all. Okay, so let's go back to the ICP, the in-class problems. See if I can get out of here. All right. So let's do this here. How do why did this come up? Like that wasn't there before. Can I hide it? I don't know. I don't know. Okay, good enough. All right, so we've talked about how to draw structures that have carbons and hydrogens, right? Now we're going to talk about the families of compounds that contain carbons and hydrogens. And a lot of times when we think about them, it's all about the connections between the carbons, right? If you have a straight chain, like most of what we've been doing so far, where all you have are carbons in a row, what you have are alkanes. Alkanes are the simplest, and you have single bonds between the carbons, and then you decorate it with hydrogens. Another thing that we call these are saturated hydrocarbons. Why do you think we call them saturated? Have you heard this in foods, right? You've heard this in foods before. Saturated fats, unsaturated fats. We're actually going to talk about fats today too. What are they saturated with? hydrogens. So they're saturated. This means they're saturated with, that's a W and a slash, with hydrogens. If you're saturated with hydrogens, what does that tell you about the links between the carbons? If you have the maximum number of hydrogens attached to you, can you have carbon-carbon double bonds? No, because all those bonds are taken up by hydrogens. So saturated hydrocarbons all have what? Carbon-carbon single bonds. And the example of that are alkanes. Alkanes. Naming alkanes is really similar to naming in terms of prefixes. So 1 through 4 are different with the prefixes by our numbers of carbons. But 5 through 10, what does that look familiar to? If you have your best friend, what does it look familiar to? Your prefixes for covalent compounds, right? So you only have 4 that you need to learn. Here, hello, what in the world? Here are your 4 that you need to know. This pen does not want to write. It was working just fine earlier. Come on. Oh my goodness. Don't do that. Okay, let me close that. Let me open it. I'm going to open it in this one. Sometimes the programs just go a little bit crazy. Okay. All right, here we go. All right, so me eat peanut butter. Do you see these? That's my little mnemonic device for remembering the first 4, because are they on your best friend? They're not on your best friend. So when you're naming these, what we have to look for is the number of carbons in the molecule is going to give us our name. So CH4 has how many carbons? 1 carbon. So 1, the prefix is meth. And if it's all single bonds, we call it an ane, A-N-E for alkane. So CH4 is methane, okay? C2H6, if I have 2 carbons, 2 is a prefix of F, and I know they're all single bonds, so I call that ane. So ethane. I sound like the Cookie Monster, right? Me eat peanut butter. That's what I think of every time I say it. But it's a good way to remember. So it's methane, ethane, propane, butane. So when we're writing this, you have to be able to go back and forth between that condensed structure and that skeletal structure. So if I picked this carbon right here and decane, how many hydrogens are attached to it? How many? 2. So for every black dot, that's a carbon that has how many hydrogens attached to it? 2. What about my end carbons, the red ones here? 3. So if I write the formula for any of these alkanes, I take my number of carbons. Let's use decane for an example. C10. To find my number of hydrogens, I take 2 times the 10. That's for all these black carbons. And then my N carbons get an extra 2. So I add 2. So that is C10H. 2 times 10 is 20 plus 2 more is 22. Did I get the same formula? C10H22. Yes, I did. That's going to be really, really important. Okay. The next class of molecules are called cycloalkanes. So these are still alkanes. Tell me about an alkane. It's all what? Carbon-carbon single bonds. So these are saturated or unsaturated? They're saturated. But what does this cyclo tell me? It's in a ring form. Okay, so I have here, what is this molecule right here? I have how many carbons? The black ones are carbons. 1, 2, 3, right? I have 3 carbons. So what do I call this? Me, E, P for pro. So this is propane, right? So what you put in your tank, the test your barbecue pit, propane. Okay. So we have propane. It's got 3 carbons on the ends, only 2 carbons on the middle one, right? I can turn that into a ring by removing 1 hydrogen, removing the other hydrogen, and then linking the 2 carbons together like this. So what happened to my number of hydrogens? Went down by how many? 2. Went down by 2. So if I look at my formula, what's my formula? CnH2n. So if I have a cycloalkane, it would be C10H what? That would be cyclodecane. Do you see the difference between decane and cyclodecane? I've lost 2 hydrogens and added another carbon-carbon bond, but I'm still saturated. I'm just saturated in a ring structure versus being saturated in a straight chain. We call this a straight chain, but is it really straight? This is why when we draw them like this, because it actually ends up looking like this in real life. That's why it's not just a straight stick, right? It actually looks like that. Okay, so if you want to draw a 3 carbon, what is 3? Me eat peanut butter, right? So this is cyclopropane. If I do 4, it ends up looking like a square. I call that cyclobutane. I have 5. It looks like this is what I call the house, right? You got the little roof over your house, cyclopentane. And then here, it's a hexagon. So if I have 6 carbons, it's cyclohexane. Okay. So we have to be able to go back and forth between structures, formulas, names, all that kind of stuff. So that's what we're going to do. So name the straight chain alkane or cycloalkane whose structure or formula is shown. C2H6. What formula does this fit? C2H. The formula is 2 times the number of carbon atoms, which is 2. Does that match? 2 times 2 is 4. So I need how many more? 2. Is this the formula for a cycloalkane or a straight chain alkane? This is a straight chain. Straight chain alkane. My straight chain alkane has how many carbons in it? 2. So what is the name? This is me eat ethane. So this straight chain alkane, this part, this is called the family. So the family is a straight chain alkane. The name of this molecule is ethane. Okay, so tell me the family for B. What do you automatically right away see? It's a cyclo. So this is a cyclo, C-Y-C-L-O. Oh, I just keep adding letters. C-L, cyclo. Do we have any double bonds? No, so we must call it in alkane. So it's a cycloalkane. That's the family. Okay, and then what is the name? Cyclo, and it's 1, 2, 3, 4, 5, and 5 is pentane. That is the name. Okay, good so far? All right, C4H10. Give me the name. I just want the straight name. So for me eat peanut butter, is butane, because why? Why did you pick butane? Because it's a straight chain that fits the formula C4, right? H, and then you're going to go 2 times 4, but that only gets you 8, so you need 2 more. So this tells me what family is it? Straight chain alkane. We're just going to do that, so I don't have to rewrite it again. Okay, it's another straight chain alkane, and it is butane. Not too bad, right? Yay! I think this is really fun, but you know, all right. Now I'm going to change the instructions. Write the condensed structure for the straight chain alkanes. I want the skeletal and the condensed. I'm going to step it up a notch. Okay, so A, butane. What does but mean? Me eat peanut butter, so it's 4. And the ane tells me it's all carbon-carbon single bonds, right? Oct, what does oct mean? 8. And what does the ane tell me? It's a single bond between all the carbons. Hexane is 6, and it's a carbon-carbon single bond. Okay, so if I want to do my skeletal first for butane, I need 4 carbons. So I go 1, 2, 3, 4. Right? Now, if I do the condensed structure, carbon 1 has how many hydrogens? 3. Carbon 2 has how many? Carbon 3 has how many? Carbon 4 has how many? Awesome. Okay, do you see how it's kind of nice if you draw the skeletal? And it takes you no time at all to draw the skeletal. And it helps you to make sure you got that condensed formula right. Okay, B, octane. So I'm going to do the same thing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to number them 1, 2, 3. So 3, 4, 5, 6, 7, 8. And remember what Dr. B says, number your carbons, right? Number your carbons. So the first one should be how many? 3, CH3. So now all of the remainder from 2 all the way to 7, how many are they going to have? 2. So the ends, the 1 and the 8, those are going to have 3, but then everything in the middle is going to have 2. So let's just write that out real quick. CH2, so that's carbon 2, carbon 3. And see, I gotta be careful with that. I'm saying the number of carbons and writing hydrogens. Okay, so this is 1, 2, 3. Carbon 4 has 2. Carbon 5 has 2. Carbon 6 has 2. Carbon 7 has 2. Carbon 8 has 3. Okay, so let's do C. So C is hexane. So we do the same thing, except we're going to do 6 in the chain. 1, 2, 3, 4, 5, 6. So I'm going to number them. 1, 2, 3, 4, 5, 6. My ends are going to be the ones that have 3 hydrogens, and then the ones in the middle are the ones that are going to have 2 hydrogens. So my carbon 1 is going to have 3 hydrogens. My carbon 2 is going to have 2. My carbon 3 is going to have 2. My carbon 4 is going to have 2. My carbon 5 is going to have 2. My carbon 6 is going to have 3. See how much nicer it is? Like it just makes more sense that way, but you don't have to, like whatever floats your boat, do whatever works for you. Okay. Now we're just doing the skeletal structure for the alkane or the cycloalkane. Just by looking at A, is it an alkane or a cycloalkane? It's a what? It's a cyclo. How do you know that? Because 4 times 2 is 8. Okay, so how do I draw C4H8? What's kind of my overall shape? It looks like a square. If I were going to number this, where would I start numbering my carbons? Just for fun. Anywhere, whatever floats your boat, start at the bottom, start at the top, start on the left, start on the right, doesn't matter. Go crazy with it. Okay, B. All right, how many carbons do I have? 1, 2, 3, 4, 5, 6, and they're all in one chain, right? So what do? That's 3, 4, 5, 6. If you're even and you start low, you're going to end up high. Like when you're doing these chains, that's just the way it works. And most of the time it's even. Not always, but a lot of times it's even. Okay, so always count 1, 2, 3, 4, 5, 6, just to make sure. But do we really include the numbers? No. Okay. C, H10, I'm sorry, C10, H22. Alkane or cycloalkane? Alkane, how did you know? 10 times 2 is only 20. So you need those 2 extra, and those are the N carbons that get those 1 extra hydrogens each. So we're going to do 10. We're going to go back and we're going to name these as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'd like to go back and name these. How do I name A? Cyclo, me eat peanut butter, bute, and then it's ane, butane. How about B? Do we do cyclo? No. So 6 is hex. And then we end it in ane. Okay, 10 is decane. Where did I get this? I'm so impressed. I love it. Okay. Now, I'm going to give you a warning here. Families of organic compounds and functional groups, right? What are the families? They're 2 different things. Families and functional groups are 2 different things. I need like extra space. Let's go back. Families. I just need extra room all the time. So families. And then substituents are functional groups. It's the same thing. Substituents or functional groups. How are they different? When you're classifying a family, what you're looking at is the parent chain. If you have carbon-carbon single bonds, what are you? You're an alkane. Okay. What if you have carbon-carbon double bonds? Alkene, E-N-E, alkene. What if you have carbon-carbon triple bonds? Alkyne, K-Y-N-E. Which ones are saturated? Alkanes are saturated. These are unsaturated. Unsaturated. So this is your saturated fats and your unsaturated fats. That's where it comes from. Okay, and then what's the other family? If you have a ring, you call it cyclo. No matter, you could have a cycloalkane, a cycloalkene, You don't really have cycloalkanes, but you know, if it's a ring, put the cyclo. Okay. Now, what are our substituents or our functional groups? Well, for that, I'm not ever going to be able to draw all of that on that one thing. So what you should do is go to your book. Is this the one what? I think like previous classes have. So, you know, it might really be out there. Y'all might really not have to do a whole lot of work. So all of these are different kinds of functional groups, different things that can be attached to the main chain. So if you want to put in a definition, right, to here, this is attached to the main chain. And this is table, what table was that? 4 point something, 4.4. Okay, so if you go to table 4.4, what you're going to see are all these different things that can be attached, right? So here at the top are some family names, and then here we get to things that are functional groups. For example, an aromatic. An aromatic is a ring structure that has alternating double bonds and single bonds. So you see here, this is a single, a double, a single, a double, a single, a double. So you can have an aromatic compound that has things attached to it, or you can have a compound that contains an aromatic. Like here, this is a compound that contains two aromatics. Sometimes you'll hear them called as benzene rings. You heard that before? Same thing. Same thing. Aromatics or benzene rings. So when you look at functional groups, there are some that you're just going to have to memorize. And then there are some that you also kind of have to think about. So y'all have heard of alcohols before, right? Alcohol is always what? OH. OH is an alcohol. And there are a couple of different functional groups that work this way. When you see the OH, automatically you should think alcohol. But you have to look at what is attached to the alcohol because it behaves differently depending on what it's attached to. So we name them as primary, secondary, or tertiary. So for the alcohol, you find the carbon that it's attached to and look at that carbon. How many R groups are attached to the carbon? So there are only ever one of two things that are going to be attached to a carbon, a hydrogen or an R group. So in this molecule, how many hydrogens do we have attached? 2. And how many R groups do we have attached? 1. So this is a primary alcohol because the carbon that has the hydroxide, the hydroxyl, excuse me, has one functional group attached to it. Yeah. If you have a carbon that has a hydroxyl and it has 2 R's, we call it a secondary. Hydroxyl with a carbon with 3 R groups. You know what R stands for? Did I say that? Rest of the molecule, right? Just the rest of the molecule. Then if it's attached to 3, it's a tertiary, right? You have combinations where you have an alcohol attached to an aromatic. If you have that, then you have a phenol, or they call it an aromatic alcohol, but it's the same thing, right? So what you need to do is you need to go in and make flashcards for all these different functional groups. And my suggestion is to do the flashcards in 3 different ways. Make one that's the name versus the picture that's in your book, right? You can do images in Quizlet. You can do it. Then do one that's the name and the description, so just the words, and then name and pick an example molecule from your textbook, right? Where it has it, but it's not highlighted, and then you have to recognize it. You know what I mean? So if I were to do that, where is it? Let's say I would pick aromatic, right? I would have the name and I would have the picture of what an aromatic is. Then I would have another flashcard that would have the name and the description. And the last one, I would have the name, and then here's an example molecule that contains an aromatic. That make sense? That's how I would do it. And I would be so surprised if somebody in a previous semester has not made a set of flashcards that are beautiful in Quizlet for this. And if somebody finds it, put it in the discussion board. You know what I'm talking about? The discussion board? Put it there, share it, you know? Don't everybody do it. Don't waste your time doing that. Okay. The other thing I wanted to show you are similar to the alcohols are the amines. An amine group has a nitrogen, and then it can have different things attached to it, either hydrogens or R groups. So if you're a primary amine, you find your nitrogen, and if you have one R group attached to it, it's a primary amine, right? If you have two, it's a secondary. 3, it's a tertiary. 4, it's a quaternary. So it's similar, but in this case, you're not looking for a carbon, right? You're just looking at the nitrogen. So go in and you need to learn some of these. You just need to go in and start studying them. The other thing that we're going to talk about today are fatty acids. Fatty acids, this is an example of a fatty acids, all contain this really long hydrocarbon tail. And then all fatty acids have what's called a carboxylic acid. A carboxylic acid, why do we call things acids? Like if I have hydrochloric acid, that's HCl, why do I call this an acid? Because when I put it into water, what happens? I get hydrogen ions and I get chlorine ions. This tells me what my pH is. The more, if I have lots of H plus floating around, I have a very low pH, right? Like fruits are very acidic, right? Because they have lots of those hydrogen ions floating around. So if I look at carboxylic acid, do you see what I have here? A hydroxyl. Guess what can happen to that hydrogen? It can come off. And that's why we call it an acid. Why do we call it carboxylic? Because all carboxylic acids have a carboxylate. A carboxylate is a carbon double bonded to an oxygen, and then either bound to an oxygen where the hydrogen has come off or where the hydrogen is still attached, doesn't matter, right? Okay, so that's one we're gonna have to really come back to, but you need to go through them. You need to go through them all, you really do. Okay, so let's go look at some examples after I've chattered away for so long. This one, okay. So, I accidentally, look, I got too excited on the video. I went ahead and did the first one in 4.18, right? I do that sometimes. So this problem is asking us for the family. Is it asking us for a functional group? No, it's asking us for the family. So when I look at this, do I name this based on the family rules or on the functional group rules? Family. So what family is this? This is a cyclo. Now I have double bonds, so this is an alkene. If this were attached to, I don't know, a string of carbons, right? Then this would be what? An aromatic. But it's not. It's a family. Okay. If I had a carbon-carbon double bond, like in A, what is it? Alkene, right? But this isn't a ring, so it's a cycloalkane. Okay, how about C? Isooctane. It's easier to name them in skeletal structure, isn't it? But do you see any carbon-carbon double bonds or any carbon-carbon triple bonds? No. Do you see a ring? No. So what must it be? Alkane. And that's the family. Okay, now we're going to look at some examples of functional groups. All right, identify all the functional groups present in the following. Oh my goodness. All right, so what do we got? I see a big old fat ring. What do we call the ring now that it's inside of a molecule. We call this an aromatic. Aromatic. I see some double bonded oxygen, and look at the end. It's a double bond, it's a carbon double bonded to an oxygen, and then it has a hydroxyl attached to it. What do we call that? We talked about that. A carboxylic, I always have to spell it in my mind. Carboxylic acid. Not the best speller. Okay, I see some nitrogens. This first nitrogen. These are amines, right? I see two nitrogens. They're both amines. This first one right here, what kind of an amine is it? So I look at my nitrogen, and I'm not looking at hydrogens. When you're naming them as primary, secondary, tertiary, don't count hydrogens, count R groups. So I have two hydrogens attached to the nitrogen. Remember, nitrogen only wants to make 3 bonds. So if I have two hydrogens attached to the nitrogen, that means I have one what? One R group, because if I drew this, right, it would look like this. And then I would have an R group. Right? And this is like R. R is all of the rest of the molecule. Okay. So what do I call this one? A primary amine. How about this other nitrogen? How many hydrogens are attached? 1. So then this bond coming off is an R group. This bond coming off is an R group. So how many R groups? 2. So this would be a secondary amine. Now, nitrogen can make a 4th bond, but if it does, it becomes positively charged. So it can happen. It can happen. All right. What else do we have? We have one that I did not talk about explicitly. Let's see if I can get a different color. How about green? So go and look in your table. This thing that I've highlighted in green, what is that? Go and look and see if you can find it in your table or in your notes or the slides or all over. Let's see if you can find it. What is it? Anybody? It's an ester. It's an ester. That's right. An ester. Now, can you find an ester in molecule in B? Can you find an ester there? It's like if you can find it in one molecule, can you find it in another? What's an ester? An ester is very similar to a carboxylic acid. What's the difference? Instead of being bound to a hydroxyl, what are we bound to? An oxygen that's bound to a carbon. An oxygen that's bound to a carbon. So sometimes it makes it easier if you look for similarities. Like how is an ester similar to a carboxylic acid, right? Okay, so let's label that ester. Okay, what else do you see in B? I see an aromatic as well. All right. Do I label that other ring structure as an aromatic? No, I do not. I do not, because it doesn't have that alternating double bond, single bond structure going on. But what's in that ring? A secondary amine. Oh my gosh, y'all are on fire. Secondary amine. Because this is an R group, this is an R group. So this, I'm telling you, is just practice. So do those flashcards and then do some practice molecules, okay? If you're in a study group, you know, like pick some molecules for your friends and quiz them, grill them, and then let them do it back to you, right? It's only fair. Okay, fatty acids. when we talk about fatty acids all have the same general structure. There's a hydrocarbon tail. So a fatty acid has a hydrocarbon tail. Now, it doesn't always have to be an alkane, but it does have to be a hydrocarbon. And then it also has, what's the other part to it? We call this a polar head group. And it's a carboxylic acid. So in a carboxylic acid, what was my structure of a carboxylic acid? I have a carbon that's double bonded to an oxygen, bound to a hydroxyl, and then bound to the rest of the molecule, right? So do you see that? Do you see that similarity? Why didn't I put a C right here? It's understood. So if I put that C there, it's not a correct skeletal structure. So don't put that C, but when you're counting, you have to make sure to include that carbon. Otherwise, you're always going to be one off. So if this is a 12 carbon chain, number them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you don't count the carbon in the carboxylic acid, you're going to be off. So be careful not to forget about that carbon. I see that all the time. Okay, so I want to draw a fatty acid found in animals called stearic acid. It is a saturated fatty acid. What does that mean? What does that tell me? All single bonds, so it's an alkane. So it's all carbon-carbon single bonds. Containing 18 carbons, draw stearic acid in skeletal structure. So I like to start with my carboxylic acid. So I'm going to draw a hydroxyl, goes up to a carbon, but I don't put the C, right? And coming off of that carbon is my carbonyl. They call a carbon double bonded to an oxygen a carbonyl. So that's the carbonyl carbon. And then I have to draw my carbons to make my tail. I already have one. This is where it gets tricky. You already have one. Now I'll go into 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. I got kind of squeezed up there. But let's count and make sure. 1, 2, 3, 4, 6, 7, 8, 13, 14, 15, 16, 17, 18. Okay. So anytime you have to draw fatty acids, if it's saturated, it is super easy. Now, if you have ones with carbon-carbon double bonds, then you actually have to explain where the carbon-carbon double bond is, and you have to do some more stuff, and we'll talk about that later. But that's the simple one. Okay. Now, we've up until this point been talking about naming things that are really, really simple, but there are all kinds of things coming off of the main chain, right? So we have to be able to name those. We have to be able to name those really, really well. So when we do that, you have to look at the groups that are attached, right? So do you remember when we were talking about here? Let's see if I can come back to it. I hate having to scroll all the way. But do you see we have families and we have substituent groups or functional groups, right? What happens if I have a functional group that is a carbon, right? What if I have a functional group that is CH3, right? And that carbon is attached to the rest of a molecule. What do I call that? I call that a methyl, right? It's not methane, it's methyl. So if you have a functional group that is carbon containing, you write that YL. So how about CH2CH3, methyl, now ethyl, right? So on and so on and so on, right? But do you see how these are functional groups and not family names? Be careful with that. All right, where was it? Here. Okay, so propyl is me eat pea peanut butter, that's 3. Methyl is 1. Okay, so give the correct name for each of the following substituents. CH2, I'm sorry, CH3, CH2, what is this? Methyl ethyl, right? So this is ethyl. How do I know that this is a functional group and not a main chain? There are 2 ways. Do you see the dash? The dash means that it's attached to the rest of a molecule. What else do you notice about this? If it were a main chain, would that be the correct? If it were a main chain, if it were ethane, what would the formula be? CH3, CH3, right? So what do you notice? The 2, right? So you have 1 less hydrogen because it's bound to the main chain. Okay, the next one. I have 1, 2, 3, 4. Me eat peanut butter. Beauty. Look, I'm about to do it wrong. Butyl. It's a butyl group. Instead of being butane, it's a butyl group. Okay, when you get to elements, what you do is you just take the beginning of the element name. So I is iodo. Instead of iodine, it's just iodo. And I'm going to show you, we're going to put all of this together in the next one. Y'all know so much now. Can you believe how much you know just for 1 class period? Amazing. Okay, it's easier to go from the name to the structure than the structure to the name. So let's do that first. So we have to draw a skeletal structure for each of the following compounds. And I'm going to tell you how I do this. Look at the name and pick the information out and write the information down before you try to draw the structure. So if I look at this, tell me about the parent. Hex, what does hex mean? 6. So I have a 6 carbon chain. 6 carbon chain. Right? Okay, now what else do I know? 3 ethyl. What is that 3 telling me? So I have an ethyl group on carbon 3. Now, do you think you can draw that? Yeah, so when you start to pick out the information, it'll be easier than just straight drawing it. Okay, so I need a 6 carbon chain. 1, 2, 3, 4, 5, 6. Now I'm going to pick carbon 3 because carbon 3 gets my ethyl group. So I'm going to erase the number on carbon 3. Can I just do this? What is that? That would be 3-methyl hexane. So what do I need to do? Put another. Now, does it matter which way I went, left or right? Doesn't make a difference. Doesn't make a difference. Okay. All right. B. 1-bromo, 3-iodo, cyclopentane. Tell me about the parent. Cyclo is a ring. What about the pentane? Pent is 5 carbon. Now, one thing we didn't say here, the ANE tells me we're all what? Carbon-carbon single. And the same thing here, all carbon-carbon single bonds. That's what the ANE tells us. Now, we have multiple substituents, right? Okay, do you see how, if you look at the substituents, alphabetically, we have bromine and we have iodine. Which comes first in the alphabet, B or I? B. So you give the substituent with the smallest letter alphabetically, the smallest number. And that's going to be really important when we draw, okay? So I just want you to recognize that, and I'm going to jot that instruction down in just a minute. But what are my groups? I have a bromine on what? Carbon 1, and I have an iodine on carbon 3, and I'll make that a 1 so you don't think it's an L. It's a fancy one. Okay, so I'm going to draw cyclo. What does cyclopentane look like? Looks like our house. Ooh, that's kind of a skinny house at the bottom. Not very good. You just want to kind of come in just a little bit. I'm not the best artist. Okay, so which one's carbon 1? Go for it. Go crazy, right? Okay, I'm going to pick carbon 1 down here in the corner. So I'm going to call carbon 1 bromine. Which one's carbon 3? Whatever floats your boat, go in a direction. Doesn't matter. I'm going to go weird. 2, 3. I'm going to put 3 at the top. So I'm going to put an iodine on carbon 3. But it doesn't really matter. Okay, count either way. All right, C. Propyl Cyclopentane. What do I know about C? So it's a ring. Pentane, tell me about that. Pentane. It's 5 carbons, okay? And then propyl. What is propyl? Propyl group, and I'm just going to put, this is 3, on what carbon? On carbon 1. We just automatically assume it's carbon 1 if it's not listed. Okay, so I'm going to do the same thing. I'm doing my house. Which one's 1? Who cares? I'll pick this one. And I'm going to put a propyl group. What's a propyl group? 1. What's a propyl group is 3. It's on carbon 1. So I go 1 carbon, 2 carbons, 3 carbons. Your homework, you have to draw a bunch of this stuff. Yeah, it's fun. Okay, but it's really good. It's really good practice. It's really good practice. All right, now we have to go the reverse way. We have to name these. Okay, give the correct IUPAC name for each of the following compounds. All right. I want to list the characteristics, then we're going to name it. So kind of like what we did before. So what do you notice about this? It's a cyclo. And what else? Only carbon-carbon single bonds. So we have a what? An ane, like an alkane. So what am I going to, and how many carbons are in here? 3 carbons. So you see how I pulled out my pieces of information, then I go build my name. So what should we call this? Cyclo, and 3 carbons is me-p pent, cyclopentane. That's the easy one. All right. Oh, pentanes, yes. Propyl. Sorry. Propyl. P-R-O-P. Cyclo. Come on. Propane. Thank you. Thank you. All right. So our next one. The first thing that I'm going to do is what? Number my carbons. I want my longest continuous chain. So what would I do? 1, 2, do I go down or up? 3, 4, 5, down or up? Doesn't matter. Doesn't matter. I'm going to go up just for fun. Right? Okay. So what do I have attached to the different things, the different parent chain? What is this? This is a methyl, right? 1 carbon is a methyl. How about F? What does F represent? Fluorine, so we're going to call it fluoro. So fluoro, I think. Not a good speller. And then what else do I have? Another methyl. Now, here's how you have to check. This is super, super important. So alphabetically, whoa, you want substituents to have the lowest number carbon. Okay. If I look, what is alphabetically closest to the beginning of the alphabet? Methyl or fluoro? Fluoro, right? Okay, so fluoro is going to have four. The others are 2 and 5. Could we renumber this molecule so that fluoro has the lowest number? Is 4 the lowest number that fluoro could have? No. What should I do? Number it going the other direction. So go 1, 2, 3, 4, 5, 6. You see that? So now fluoro has the lowest number it could possibly have. Yes, you have a methyl that's 2, and yes, you have a methyl that's 5, but fluoro got the lowest number it could have. That's how you know what to number it. So I'm going to erase my black numbers because they're not right. It was the right number of carbons, but it wasn't numbered in the correct way. That makes sense? Okay, so now how do I name this? Let's do the parent first, right? What do I know about this? I know it's a 6 chain. So 6 carbons, what do we call it? Hex, and then it's all carbon-carbon singles, so it's ane. So we go alphabetically, what's the first one? We have 3 fluoro. Then what do we have? Go with the lowest number possible. 2, 5, but do I just do that? 2, 5? No, because that's saying 25. So I need to put a comma, 2, 5. I can't just say methyl because actually there's more than one methyl. There are how many methyls? 2, so it's dimethyl. And then parent is hexane. Hoo-wee, huh? Yeah, it's much harder to go from structure to name than it is from name to structure. Because when you do it from name to structure, you draw it, right? But here, it's already drawn for you, and you have to name it properly. So there will be multiple choice on the exam where you have to go both ways. Warning you now, you'll have to go both ways. Okay, C. What do we automatically notice right away about C? It's a ring, so what do we call it? Cyclo. Okay, how many carbons are in there? Cyclo with 6 carbons. So what are we going to name the parent? Cyclo. C-L-O. I don't know why I added another E in there. C-Y-C-L. Cyclo. Hexane. Okay, how do I know where to start numbering? I need to name them. So I have 3 substituents. What are my 3 substituents? They're all methyl groups. Okay, so I need to give my methyl groups numbers so that they will all have the lowest numbers possible. So do I start with the one by the letter C? No, I need to start on the other side of the molecule, right? So which one gets it first? The one that's flat or the one that's pointing up? The flat one gets a 1, right? Now, do I go down or do I go up for numbering? Up, 2, 3, 4, 5, 6. I'm going to prove it to you that that's the right way to do it. Because if I went, let's just say, there's another way too, though. You could go 1, Now, do I go down to the left or do I go to the right? I could go this way too, right? But what's the problem? Do you see how the methyl gets either a 5 or a 4? Which one does it need? It needs the 4. It needs to be the 4. So make sure that you're very careful about that numbering system. Okay, so what do we call this? 1, 2, 4 trimethyl cyclohexane. Yeah. Alphabetically, you want substituents to have the lowest number of carbons, and you can put it up here. And substituents should have the lowest numbers possible. Right? Because let's say you had this cyclo right here, cyclopropane, right? And you had 2 methyl groups. How would you name that? You have to start with one of them, right? You have to start with one of the carbons that has the methyl group. Then can I go to this corner? No, because that would give me 1,3 dimethyl. I don't want 1,3 dimethyl. I need to go 1, 2, 3. So then I get 1, 2 dimethyl cyclopropane. But what if I had this? Is my numbering correct now? No, why not? Because methyl starts with an M. Whoa. Methyl, right? Starts with an M. Bromine starts with a B. So I want to give that 1, 2, 3. So it would be 1 bromo, 2 methyl cyclopropane. Practice, practice, practice. There are extra problems at the back of the chapter, and all the answers to the odd numbered questions are in the back. So try them and make sure that you're getting the right answer. Okay. All right. Yeah, sure. We'll quit there. Yeah. Okay, let me see. Anybody on the chat need anything? Anybody on Zoom need anything at all? Okay. I'm gonna go ahead and end the Zoom.